Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to use your KW in calculations. So these are pretty straightforward calculations. A lot of times you're going to be given an H plus concentration or a hydronium ion concentration, or you're going to be given an OH minus or hydroxide concentration. And so you're going to be asked to figure out what the pH or what the hydroxide or hydronium ion concentrations are going to be. In this case, it's pretty simple if you know the Kw value, which you should, because that Kw value at 25 degrees is a constant at 1.00 times 10 to the negative 14 molar. And you should have this equation in mind. So if you know this, your Kw is equal to the H3O plus concentration multiplied by the hydroxide ion concentration. So as long as you know this and you're given either the H plus concentration or the hydroxide ion concentration, you should be good. Okay, so how do we do this? Well, here all you're going to do is plug in the given values into here. You know that this is equal to 1.00 times 10 to the negative 14 molar. And so when you're solving for this, then you're just going to plug one of these into the equation and solve for the other part. So it's that simple. So here we have the H plus or hydronium concentration of 7.5 times 10 to the negative 5. So we're going to plug this into our equation. So that means we have 7.5 times 10 to the negative 5 molar. And this is actually molarity times molarity, so this should be molarity squared, actually. And so we have this multiplied by the OH minus concentration equal to 1.00 times 10 to the negative 14 molar squared. So when you solve for OH, you're going to get, if we look it up really quickly, we're going to calculate that value to be it's going to be 1.3. So here your OH minus concentration is equal to 1.3, I think, times 10 to the 10 times 10 to the negative 10 molar. So if we want to find out if it is acidic, basic, or neutral, since our OH concentration is less than 1.0 times 10 to the negative 7, which would be neutral, this is less than that, so we have less OH minus concentration. So we're going to have a higher H plus concentration, which is what we have here. So going back here, we could see, okay, our H plus concentration is higher than 1.0 times 10 to the negative 7. So that means we have an acidic solution. All right, so what about this one? Same thing. All we're going to do is we're going to plug into this equation 1.5. So here we have 1.5 times 10 to the negative 9 molar times OH minus concentration equals 1.00 times 10 to the negative 14 molar squared. We divide both sides and we get an OH minus concentration. Give me a second. the concentration is going to be 6.7 times 10 to the negative 7. So this becomes 6.7 times 10 to the negative 7 molar. And once again, we're asked, is this acidic, basic, or neutral? So here, if we go back to our H plus concentration here, it's 1.5 times 10 to the negative 9. That gives us 6.7 times 10 to the negative 7. Oops, I made a mistake. That should be number 6. I thought that was not right. So you can see here that the OH minus concentration is greater than 1 times 10 to the negative 7. So we have more HO minus, more hydroxide ion than we would expect for neutral. That would mean that that's basic. We could also go over here and say, well, we have less H plus concentration than 1.0 times 10 to the negative 7, which would be neutral. So, but we have less H plus, so again, that would be basic. So our answer here is it's basic. So this is acidic. This is basic. And right away, we could see this is our H3O plus concentration is 1.0 times 10 to the negative 7. That is neutral. And of course, if we do the calculation, which we don't have to do because we should recognize this as neutral, but they're asking us to calculate it, so let's do it anyway. So it's 1.0 times 10 to the negative 7 molar for your H plus concentration multiplied by OH minus is equal to, again, 1.00 times 10 to the negative 14 squared. And then when you solve for your OH minus concentration, you're going to end up again with 1.0 times 10 to the negative 7 molar. So we have a neutral. So this would be neutral. Okay, so that's that first part here. What if we're given H3O plus concentrations, or if we're given OH minus concentrations and we're asked for the H3O plus concentrations? So, and again, we're asked if it's basic, acidic, or neutral. Same thing, no different, except that now we're given the hydroxide ion concentrations. So we set up our equation again. So this time we're going to have our H3O plus concentration multiplied by the concentration they're giving us, 1.5 times 10 to the negative 2 molar. Again, that's equal to 1.0 times 10 to the negative 14 molar squared. And so we just solve again. So here, now we're solving for the H3O plus concentration. And if we do that on the calculator, okay, and we get 6.7 times 10 to the negative 13 molar. So we look at that answer. Our H plus concentration is much less than 1.0 times 10 to the negative 7. So therefore, it's going to be basic. And we can see here that our OH concentration, our OH minus concentration, is much higher than we would want for a neutral solution, which is 1.0 times 10 to the negative 7. So again, this would be a very basic solution. So this is basic. Okay, what about OH concentration of 1.0 times 10 to the negative 7? Again, right away, we know that the OH concentration represents a neutral solution because we should know that OH minus concentration of a 1.0 times 10 to the negative 7 is neutral. We would do the same exact calculation that we did here. The only difference is that we would now be solving for the H3O plus concentration. So exactly the same setup here. So just to be complete, we would have our H3O plus concentration multiplied by 1.0 times 10 to the negative 7 molar is going to be equal to 1.0 times 10 to the negative 14 squared. And then you would solve, and then of course you would get an H3O plus concentration is equal to 1.0 times 10 to the negative 7 molar, and that would be neutral. Okay, what about your OH minus concentration? So for your OH minus concentration, here you have 8.2 times 10 to the negative 10 molar. Okay, same calculation. So we're going to do H3O plus, and then multiplied by 8.2 times 10 to the negative 10 molar. And that's going to be equal to 1.0 times 10 to the negative 14 molar. And then solve for the H plus concentration. Okay, and that would be an H3O plus concentration of 1.2 times 10 to the negative 5 molar. And once again, the H plus concentration, you can tell that that's going to be greater than 1.0 times 10 to the negative 7. So this would be acidic. You could also tell here that your OH minus concentration is less than what you would expect at neutral. So since it's less, again, it's going to be acidic. So this is acidic. So I hope this was helpful. If you like this video, please like, share, subscribe, hit the notification bell. And thanks for joining me, and I'll see you next time. Thank you.